The mulberry tree serves as an example of a species whose biology and life cycle defy traditional categories of biological classification. Analyzing their ontogeny allows for a precise determination of the lifespan of individual developmental stages, as well as enables a generalization of the total vitality of the organism. The collected data comes from both field observations, and from the corporate documentation, Wayland provides a consistent picture of the lifespan of this species under various environmental conditions and with varied stress factors. The egg stage, commonly referred to as the Moors, is characterized by an exceptional ability to survive for a long time in a dormant state. The external structure resembles an organic cocoon. Filled with a better medium of nourishing and protective function, observations indicate that eggs remain active for a period measured not in months or years, but in decades and likely even centuries. This mechanism allows them to wait for the appearance of a suitable host. From the perspective of comparative biology, this phenomenon is similar to the fertilization known in terrestrial organisms such as tardigrades or some species of nematodes, which can reduce their metabolism to almost zero. According to corporate data, they were found on heroin in an alien ship by the Nostromo crew and could have been stored there for 10,000 years. Then, after the opening of the wharf, a face emerges from it, whose lifespan is extremely short. All observations indicate that this organism serves a one-time function. It implants the embryo into the host's body and then dies. The lifespan of the face claw, counted from the moment it leaves the egg to its death, lasts only hours or, at best, days. This is a transitional phase. Focused solely on ensuring the continuation of the species in the next stage, there often appears a parser that leaves the host's body in a violent act of tearing apart the chest. This transitional stage of the development of the son of Worf grows extremely quickly and often undergoes a complete metamorphosis into an adult individual in a very short time, usually within a few hours. The lifespan of the time as a partner is therefore minimal and always subordinated to a quick transition to a form capable of independent functioning. The most recognizable stage is the adult individual, which most often takes the form of a worker or warrior. Data indicate a high variability in the lifespan of this caste under natural conditions in the absence of external threats. Adult offspring of the OFE can function for decades, characterized by their ability to slow down metabolism and even enter a state of hibernation, allowing them to survive periods of food scarcity or unfavorable environmental conditions. There have been cases of finding adult individuals retaining full functionality after decades of isolation. This phenomenon indicates the presence of biological mechanisms analogous to diapause in insects, but developed at a much more advanced level. The queen holds a special place in the colony. This organism is many times larger and whose function is long-term egg production. All indications suggest that the queen's lifespan significantly exceeds that of ordinary individuals. Under favorable conditions, she can exist for hundreds or even 1,000 years, and her reproductive activity shows no signs of rapid decline. With age, the similarity to the social structures of insects, such as termites and ants, is clear. There, too, queens are capable of living many times longer and maintaining colony stability. In the case of xenomorphs, it can be assumed that the queen serves not only a biological but also a structural and social function, and her survival determines the existence of the entire population. In summary, the lifespan of xenomorphs depends on the individual developmental stage of this alien. Their entire life cycle indicates that this species bases its evolutionary strategy on a combination of extremely short-lived developmental phases. The exceptionally long-lived passive reproductive forms and the life dynamics thus constructed make the xenomulberry one of the most adaptive and resistant species known to science, capable of surviving in almost any environment for periods of time beyond the limits typical of animal organisms known to the Earth's biosphere. Thanks for watching the video. Don't forget to subscribe and give a thumbs up. See you.